Okay, assignment 2, let's preview. Question 1, it says a histogram of the distribution of salaries of non-administrative personnel of a company is given in the figure below. What you see here is a graph. We talked about 3 different types of graphs. You see here these the bars are attached to each other, and we remember the attached bars would create a graph that is called a histogram, and it's useful for continuous data. And you also see the word histogram here, right? A histogram is given below. So this is a graph of this company salaries, right, given out at this company. And you see the numbers 20, 21, 22, and so forth. And they should be read in thousands of dollars. So 20 represents 20,000, 21 represents 21,000, 22 represents 22,000, and so forth. And you also see the graph has little dots that we can create that represents where above these numbers, right? So when we say 21,000, we see that that's where this mark is that we just created. But we see the graph actually goes further down and then further up. So to think about the salary bracket then of this particular bar, we're actually talking about halfway below this, which would be 20,500 to 21,500. 21,500. Okay. So that's how we want to read the graph. In the vertical line here, you see relative frequencies. A graph that we've seen earlier just had, or the graphs we looked at had frequencies. The shape remains the same, and the scale here is then just on a relative frequency scale that's similar to the percents that you would see. So here are the questions. First one, what percent of salaries are between 23,500 and 24,500? So when we go back to the graph here, we're looking for the percent of between 23,500 to 24,500. That would be this one here. And you can see the height of this would be right here. So the relative frequency is 0.04, and we can easily convert that to 4%. The second question is what percent of salaries exceed 26,500? Okay, so which is to say, what percent of people make money, salaries, above 26,500? So we want to locate 26,500 right here. And the question is, what's the percent of all of these people here, right, to exceed 26,500? So you want to figure out the relative frequencies for each of these 4 and then add them together and convert it to percent. Or to say, well, this is 6%, right? This is also 6%. This here is 2% and another 6%. Okay? And you can add them together. All right. Now here's a big question. Question C. Assume the histogram is based on 400. Construct a frequency distribution that corresponds to this histogram. Now what it's giving us is your total N. Okay? So that's going to be the total N. So the question is, can you create a table that this graph represents? The first thing we want to do is create a column called salaries. And we know that typically frequency table begins with the highest number, right? In this case, highest salary. And that's going to be represented by the number 30 here. To read this graph, it's going to be between 29,500 to 30,500. And that's going to be the first item on there. And the next one, the number 29, is representing 28,500 to 29,500. Okay. So in a similar way, you will write down all the salaries all the way down to the bottom, and all the way down to where the number 20 is what that is representing, which would be 19,500 to 20,500. Okay. Now that is salaries. And then what's given in this histogram is relative frequency. Okay, so let's put that down. So I'm listing the relative frequencies because that's what's given in the graph. So for the number 30, we're kind of reading the graph backwards, right? Because we start out with the highest. The relative frequency is going to be 0.06, right? That's right off the graph. And the next one down for the number 29, the salary bracket there, the relative frequency is 0.02, right? And then we're going to be able to list all those things down. And what would you say is the relative frequency above the number 20? Okay, all the way at the bottom, it would be another 0.02. Okay. So this much, we're getting it out of the graph. Okay? But the question is asking how many people, right? Assuming the histogram is based on 400 people, construct a frequency distribution that corresponds to this histogram. So we want to be able to figure out, based on this, how many people would fall under each interval if you had a total of 400 people. Right? So we're going to calculate the frequencies. So the frequencies all have to add up to n of 400, because that's what's given. Right? So how do we go from a relative frequency of 0.06 to the actual number of people that make that much money? Earlier, one small formula that was given was to find the relative frequency, right? Which was frequency divided by n, right? But this time it's frequency that we're looking for. So we can kind of switch this formula around to mean the same thing, but to calculate for frequency, we could put frequency on one side. So calculating for frequency would require turning these things around. Relative frequency times n. So frequency for each of these would be to calculate the relative frequency by 400. To calculate then for these things, and they will become your frequencies, and they should add up to 400. And then it says in question D, again assuming 400 people, how many employees had salaries between 25,500 and 26,500? Well, if we had, once you have the table all completed, that would be just a matter of reading off the table, right? But we can also see, just answer that question just based on the graph. So the question is, what percent, or how many people make salary between 25,500 and 26,500, and go right to the graph here and say, well, we're talking about this here, right? So we can see that the relative frequency is 0.18 or 18%. So then we just calculate what 18% would be of 400, and that will tell you how many people actually fall into this category. All right. Let's look at number 2. Given below are a collection of scores on a spelling test. So here's a lot of numbers here. They're random. And so the question is, can you organize these numbers by creating a frequency distribution and computing the relative frequencies as well as cumulative frequency. So the table that you want to create, and these are scores. So we want to say scores. And we want to list from the highest to the lowest, right? So we start with 10 being the highest, and we want to list in sequence then all the other numbers that occur. And typically in a table, you want to look for or present a frequency, right? So frequency, if you remember, is how many times each score occur. So completing just that first line, we see that 10 is only there once. So the frequency for that would be 1. And the question also asks for relative frequency and cumulative frequency. So relative frequency cumulative frequency. So relative frequency, if you remember, the calculation is frequency divided by n, right? So in this case, let's count how many scores we have and what our n is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So n here is 24, right? So that's going to be divided by 24. And that should give us your relative frequency. Now, the cumulative frequency has to be done at the very end, right? Because you're adding the frequencies from the bottom to the top. But I also know that the top number in the CF column has to be the same as your total n. So I'm just going to put 24 there because that's where I want to end up once I start adding up the frequencies from the bottom to the top. So see if you can fill out the rest of the table, but this is what a table for this question would be. Here in question 3, it says to construct a frequency polygon for the distribution shown below. Now, a polygon, if you remember, is connecting the dots, right? So it's the third type of graph that we looked at that just has one line that we need to anchor to the horizontal line, right? So let's look at this table here. Here we see in the X column, we see a range of scores, right? So this is the first time we're looking at a table that has not an interval size of 1, but an interval size more than 1, right? So here we look at 95 to 99. That's a range of scores that puts together the score 95, 96, 97, 98, and 99. So if you were to count the total or the total number of scores represented in this range, I count 5. So that's what I would say is the interval size, right? So the interval size here is 5. Okay? Here you see frequency, the frequencies here, and with the n of 80. Now, to draw a polygon, so in a polygon like this, the horizontal line is going to represent x variable. And because we're looking at ranges of scores here, and also because we're connecting the dots, so let's just go and list the number that is in the middle within each range. So between 40 and 44, the number in the middle is 42. Okay, so with this being 0, let's just go with 42 here. And the next middle number is going to be between 45 and 49, and that's going to be 47. And the one above that, the middle number is going to be 52. The one above that is 57, and so forth. So you see a pattern. Right, and these numbers are skipping by 5 points, right, because the interval size is 5. In the frequency column, or the vertical line, you see the highest number is 15, and so we want to have a range, a scale that goes up to 15. So maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, or something like that. All right, so here we're reading the graph from the bottom to the top. So now we're ready to draw. So the number 42 is representing the range 40 to 44. The frequency is 2. Okay, so that's going to be 2. Okay, 47, the frequency is 0. Okay, so I'm already able to connect the dots so far. Okay. And then 52 is representing 50 to 54. The frequency is 4. On my way to creating the polygon. We also want to make sure that once we're done, we're either connecting or putting a dotted line to connect it down, anchor it down to the horizontal line, or a solid line somewhere with 2 dashes. Okay, so see if you can try drawing the polygon. And lastly, in question 4 is the table of frequencies below. And we want to try calculating or practicing calculating the percentile rank for these various scores. So in order to do this calculation, the first thing we notice is that there's, again, a range of scores here, right? So let's look at 45 to 47. What would be the interval size here, right? We could count with our hand. 45, that would be 1, 46, and 47. So 3 numbers are represented here, and that would be the same for each interval. In fact, this is how the data was organized, right? With 3 numbers representing each interval. All right, so the interval size there. Another thing that we need in order to calculate for percentile is the CF column. And again, CF column is to add the frequencies from the bottom to the top. So we need to create that table before we can plug in the numbers into the formula using each of these 5 scores. So let's just start the CF column. Frequency column begins with 4, so I'm going to begin with 4 in the CF column. And then to add 7 more to that makes it 11. And then to add 9 more to that makes it 20. And then to add 12 more to that makes it 32. And then to add 15 more to that makes it 47, right? So you want to go all the way up. Right? So now we're ready to calculate for percentile rank. The first one is the score of 31. So the first thing you want to do is look for that number, 31. It's right in here. So my interval that I'm going to box in, so I'm going to need, according to the formula, the frequency within, the CF below, and then the actual score is 31. But what would be the lower real limit? Right? The lower real limit is halfway down from that interval to the next. And this can be a little confusing here, but the gap between that interval that we just boxed in and the one below jumps from 30 to 29, right? From that interval to the one below. So you want to go halfway down there, right? Between 30 and 29. That makes the lower real limit of 29. So you have the interval size of 3. So these are the numbers that you need to plug into the formula to calculate for percentile rank. So try the same procedure then for the remaining scores that you see here, the scores of 42, 26, 41, and 23, to get a hang of using the percentile rank formula.